Hi everyone, I'm Zhengwei. I'm very glad to share my topic called Streptococcus thermophilus in dairy products. This presentation will follow in 7 steps. Firstly, I would like to introduce the Streptococcus thermophilus. It's one of the lactic acid bacteria, which are a group of microorganisms capable of transforming carbohydrates. And Streptococcus thermophilus are always used to ferment yogurt and make cheeses. According to the statistics, about 40 billion American dollars are used for it in annual market. So it's significant to research this kind of stress. So what are the functions of Streptococcus thermophilus? It can be treated as a temporary probiotic, and it's effective for infant diarrhea, enterocolitis, and inflammatory bowel disease in premature infants. It also has a lot of other positive effects, such as producing antioxidants, promoting the lactose digestion of the lactose intolerance, stimulating the intestinal immune system, to reduce the risk of some cancers, such as the reduction of intestinal and vaginal infections or resistance mutations and anti-cancer, and reduce risk of ulcers and inflammation. Phenotype characteristics of Streptococcus thermophilus are explored. Because of the difference of metabolism, galactose in milk could only be used by 25% of the strains. This means that Streptococcus thermophilus strains are highly different, and galactose cannot be used as conditions to select and optimize Streptococcus thermophilus. What's more, the property of raw BEPS determines the gelling property and the rheological properties of Streptococcus thermophilus. Streptococcus thermophilus also showed the characteristics of weak post-acidification ability. The research of genotype characteristics of Streptococcus thermophilus shows that Streptococcus thermophilus is related with pathogenic species, but it's safe for humans because Streptococcus thermophilus lacks of the proteins that expose from surface of pathogenic Streptococcus thermophilus. Streptococcus thermophilus doesn't have the essential factor of virulence, and it can be proved as a food-grade microorganism. Moreover, nitrogen metabolism can be maintained well by Streptococcus thermophilus, and their ability to metabolize nitrogen is essential for acidification process to be efficient in milk. Thirdly, the formation of a large number of aroma substances in fermented dairy products is related to the catabolism of amino acids. Glutamate dehydrogenase activity is generally higher in Streptococcus mufflers. This means glutamate dehydrogenase activity levels are dependent on stress. So we can find the correlation between genotype and phenotype characteristics. That is, genotype determines phenotype. Both researches about genotype and phenotype characteristics of Streptococcus mufflers show that most Streptococcus mufflers can hydrolyze urine. The properties of EPS are determined by the genes, and Streptococcus mufflers can ferment 5 sugars, which are galactose, mannose, glucose, lactose, and sucrose. Finally, the related biotechnology is researched. Genetically engineered Streptococcus muffler strains can enhance anti-inflammatory activity, which means genetically engineered Streptococcus muffler strains have positive effect on treating inflammatory bowel disease. Mutation breeding is another method. High-yield EPS strains and the strains with rheological characteristics have been bred. This means biotechnology is a good approach to breed new strains which the market needs. So, what should we do in the future? The research of Streptococcus mufflers is always carried out in traditional strain screening, which has the disadvantages of repeatability. The evolution of Streptococcus mufflers is slow, and the screening of specific strains cannot match the needs of modern food industry. So, genomics and various model biotechnologies have become new research objectives. Firstly, modern biotechnology can deeply study the genes of Streptococcus mufflers. Secondly, it can transform Streptococcus muffler strains, matching market demand more quickly. Thirdly, it can also make professional identification on the safety of new Streptococcus mufflers. With the development of biotechnology, genomics together with transcriptomics, proteomics, and metabolomics has formed a system biology which can fully understand the nature and characteristics of organisms. System biology will gradually integrate biological theory, mathematical model, and applied computer to form an overall analysis model of bioinformatics and system biology, which will introduce a new stage for the research of Streptococcus mufflers. And I believe in the future, the biotechnology will become the main and advanced method to analyze the Streptococcus thermophilus information. Thank you for your watching.